So for mode 1, we know that S1, S5 and S6. 1, 5, 6 just now. 2 pair on the top arm, 1 pair on the bottom arm. But for mode 2, we have S1, 2 and 6. So 1 is connected, 2 is connected, and 6 is connected. So if we draw in terms of our mode, for mode analysis, so we can see that there will be 2 sets of resistor on the bottom, 1 set will be on the top of the circuit. Okay, so the middle node is neutral. So here you have A, B, C. So here is node A, neutral, B and C node. So we can see that B and C will share the same level of voltage. So VBN is equal to VCN. Meanwhile, we have VAN of its own voltage level. So this is V source. So as we know, for single resistor, the voltage drop is 2/3 of V source. Meanwhile, for pairing of resistor here, the drop is 1/3 of V source. So two resistor in pair, the resistance will be lower, so voltage drop is low. Higher resistivity, this is the voltage divider rule, single resistor. So we have here the voltage drop is 2/3 of the source. So we have here VBN and CN here is negative. So negative actually. VBN and VCN are at negative poles or negative sequence. Then we go back to the chart. So you can see that for VAN we plot just now at 2/3 of the level. Meanwhile, BBN and CN share the same level of negative 1/3 of V source. Next we go to mode number 3. For mode number 3, the corresponding what's so-called switch is 1, 2 and 3. 1, 2 and 3. So if we take a look at this graph again, so 1, 2 and 3, and 1 just now is mode number 2. Now we go for mode number 3. So for mode number 3, 1, 2 and 3. The other are all off, 1, 2 and 3. So the branch, we can draw 2 pairs on top. Meanwhile, we have it's connected to our source. So this is A, B and C. So V, this is neutral. VAN is equal to VBN equal to 1/3 of VS. Meanwhile, VCN now is equal to 2/3 of V source. So we go back to the chart. So VAN and VBN sharing the same voltage level. VAN and VBN. Meanwhile, the VCN is negative 2/3 of the level. So same with sequence number 4, we perform the same step. We can see that VAN and VCN share the same level of negative 1/3. Meanwhile, VBN will be 2/3 of VS at positive level. And we go for the 5th step mode. You can see later that VAN and VCN are same. Sorry, VBN and VCN are at same level. Meanwhile, VAN at negative 2/3. And mode number 6. Let's say if we go to mode number 6. So number 6 will be like, that's now mode number 3. 4, 5, almost the same step. And if number 6, we can see that the switching device is on 4, 5, and 6 here. So 4, 5, and 6. Number 4, 5, 5, and 6. 4, 5, and 6. So almost the same like mode number 2, but in terms of labeling, means that it comes into A, it comes into C. So C is here. It goes out into A and B, B and A, almost the same. So it means that we have here VCN, which is 2/3 of VS, and VBN is equal to VAN, which is 1/3 of V source. So VAN and VBN is negative because it's on the negative poles or negative sequence. Positive 2/3 for VCN, negative 1/3 for VAN and VBN. So we can see here negative 1/3 kan. Mode number 6, negative 1/3, positive 2/3. So after charting each of the sequence, so what we need to do is we just connected the lines between each of mode. So we shall see the pattern. So after one cycle, actually it repeats itself for another cycles. Same like the first cycle. So we can see that we have a sinusoidal like of wave. Same goes to the phase B and phase C. So we just connect all the lines together. So we can see that we have a waveform that shifted like this. Okay, so this is the waveform of V line to neutral. So for V line to line, actually V for VAN, so VAB is equal to VAN minus VBN. So VAN here minus VBN, so we shall get VAB. Same goes to VBC. BC is equal to VBN minus VBN. VCN. VC is now for VCA is equal to VCN minus VAN. VAN minus VBN, VBN minus VCN, VCN minus VAN. So you minus the above. Let's say for we are charting for VAN and VAB just now, this one. So VBC is one, VCA this one. VN minus VBN, 1/3 minus for VAB, 1/3 minus negative 2/3. So negative is positive, we get 3/3 positive. So that's what we have here, VAB of positive. We calculate for VBC, we shall get negative, and 0 for VCA. So you follow the same pattern or sequence for mode number 2, you shall get positive, 0, negative. For line to neutral, the maximum is 2/3 of the level. But for line to line, the maximum is the level of source voltage. So we shall get for another mode, mode 3, 0, positive, negative, then we shall get negative, positive, 0. So when you connect all the lines, we shall get a 3 level of output voltage for line to line of this pattern for red, yellow and blue. So this is the sequence or the steps you need to perform to get or to understand or to analyze all the modes here or all the process here. So what you have to do is that you draw the circuit so that we are able to indicate which circuit placed at which part. Then we draw the switching pattern which is shifted 60 degrees each other. So for switching pattern 1 up to 6, then we assign in terms of their mode analysis. For mode number 1 to 6, so for mode 1, which switch is on. So you perform each of the mode, the analysis of each mode. So we chart the graph for line to neutral and then only line to line. So then once we chart, we just interconnect all the mode, we shall get the waveform. Okay. So this is the step you need to perform. Same to the 120 degrees analysis. It's just that for 120 degrees analysis, only 2 switch connected at each mode. For this 180 degrees, for 180 degrees, 3 switch. For 120 degrees, only 2 switch connected. So that's why we can see that inside our 3-phase inverter for 120 degrees connection, only 2 switch connected. Sorry, this is 180. Okay, 120 degrees, only 2 switch at any mode. 1, 2, 3, 4, 5, 6, only 2 switch connected. So the equivalent resistance, you find out the equivalent the current, then the voltage drop across each of our branch. So you generate the 3-phase sequence of the switching, 120 degrees apart of each other. Go for V line to neutral, then for line to line. So you can see that the pattern of the output same like 180 degrees, it's just